Hi everyone, this is Shannon Williams with Rancher Labs. Thank you all for joining us for today's online meetup. Looks like we have a good crowd here, and we're going to be going through a lot of interesting topics, specifically focused around k3OS, a new project we announced a couple weeks ago. I am joined today by one of my co-founders, Darren Shepard. Darren and I have been hosting this online meetup forever. Darren, you still there?
Yep, I'm here.
Awesome. So I run all of the marketing and sales here at Rancher. Darren is our chief architect, and we're really going to be walking you through k3OS today. Hopefully, we'll have a chance to demo a lot of things, show you this new project, what we built, why we built it, answer all your questions. As always, we try to run these online sessions a little different than your typical webinar, and really model it after a meetup. So, for those of you who've attended before, this is all old hat, but if it's your first time coming, we do things a little bit different when we run these online meetups every month. They are meant to be interactive. There's tons and tons of questions that come in. We don't set any kind of time where we target ending. So, we try to get done in an hour and a half or so, but it's not uncommon at all, depending on the topic and how many questions we get, for stuff to go quite a bit longer. We take questions continuously. So, as something comes up or a question comes up, please use the questions tab in GoToWebinar. And as you put that in, we'll see it. We may respond in the chat. We might respond. I might repeat your question out to Darren, for example, or he might stop me and mention a question that he's seeing in there. Don't really worry if your question is really, you may tag it in private if you don't want us to mention it publicly, but you're kind of lost a little bit or you need some help. We'll certainly get to it. The other big thing is we do live demos on these. So there is no, there's no canned demos. We show everything live. We'll show you the real technology, how it works. And if there's something you'd like to see that maybe we're not showing, feel free to ask. We'll try to incorporate that into what we're planning to do. Because of that, stuff sometimes breaks. We're often showing alpha software relatively early in the life cycle, as in today. And we're relying on cloud providers for infrastructure. So just with lots of different moving parts, it's not uncommon for us to see some issues. Be patient. We can usually work around them and hit the main content. The other most common question, are we recording? We are recording. All of these go up on our YouTube channel. You can see any of these, the monthly meetups or anything else there. If you go to that channel, you'll see a playlist with all the meetups, and you can find good content from past meetups, good topics. If you're new, there's tons of great stuff on there. There's a couple ways to get involved as a meetup. Because we are doing this with a global audience, we end up with people from all over the world. If you're new or you're coming here for the first time, please introduce yourself. We use a hashtag RancherMeetup for Twitter conversations. You can post a picture, show us what you're doing, introduce yourself to the group. We'll stick you up on our 100 deep level of these pictures and welcome you to the community. So please don't hesitate to use that. We also have in the Rancher Slack channel a channel specifically around the online meetup where we can have discussions. Because we use the questions in here, this is usually used by people maybe if you want to talk one-to-one or you want to ask questions outside of this, feel free to join the channel. You can find this at rancher.slack.io slack.rancher.io and join the Slack and join the Slack discussion. So with that, I'll give you just a really quick introduction to Rancher for anyone who's new to Rancher, and then we'll be diving into our main content today. I'm going to talk a little bit about what drove us to build k3OS and our goals around collapsing Linux, Docker, and Kubernetes into one atomic unit that could be managed. And then Darren will go through a little bit more detail on the architecture and dive into a lot of demos and show you how to get started with k3OS and talk a little bit more about where it is in its life cycle, where it's going, and then we'll wrap up with questions and getting started type of stuff. So without much further ado, I'll jump into just a quick overview of Rancher. So for those of you who don't know Rancher, we're a software company. We're been growing a lot now. I think we're about 140 people around the world. We build open source software to help companies use and manage Kubernetes. And our most popular project is called Rancher. Rancher is an open source management platform for Kubernetes. It's used by 20,000 teams to manage their clusters and really provides a great platform for teams looking to find a way to manage all of the clusters of Kubernetes, all of the implementations with a central implementation of security and policy management. So what Rancher allows is for teams to, deploy Rancher and use it to either provision or import Kubernetes clusters, whether they're hosted like a GKE or they're provisioned onto bare metal, while providing kind of a Kubernetes as a service experience for consumers of Kubernetes within an organization. So you can provision a cluster and then allocate namespaces, or you might provision a whole cluster for a different group. What's so great about it is that it integrates this operations management for the IT organization to manage how people can access Kubernetes, what type of policy you build around it, how to manage capacity and monitor them, with a really great user experience on the other end. So it provides not just a UI for managing the application, but also monitoring with Prometheus and logging with FluentD and alerting and integrated CI and just all the stuff you need to really leverage Kubernetes to transform how you manage applications. So if you haven't had a chance to play with Rancher, you can learn about it on rancher.com or go to its GitHub page. The whole thing is open source and very popular. But these days we're working on a lot of other projects. We announced a project called K3S a couple months ago. We have this new k3OS. There's projects like Submariner, which we rolled out not too long ago. And more, the work we're doing is really helping teams figure out how to deliver Kubernetes everywhere. And that's driving a lot of the conversations we're having now as people think about, Kubernetes not so much just as something to run in the data center, but rather, kind of a ubiquitous management plane that's gonna exist everywhere. And that's really the topic of our conversation today is really as we look forward and think about Kubernetes appearing, more and more in more and more places, how we manage it and how we sort of integrate it with Linux become interesting topics to dive into, and good opportunities to think about how how we might be able to do things better. And so the k3OS project really started with K3S. K3S was a project we announced back in March, and it's a micro distribution of Kubernetes. For those of you who aren't familiar with it, it's basically looks at it's an upstream implementation of Kubernetes, but where we've removed a lot of the non-essential components like alpha code and cloud drivers and other things that most people don't consume more than one of, and they can inject if they need. Or and in doing that, we were able to shrink this footprint of Kubernetes pretty dramatically by about 3/4 the size. So that's both in terms of the actual amount of disk it takes up, but more importantly, the memory consumption, where we could get this down to about 1/4 of a gig, or somewhere in there of memory consumption on the host. The other big thing we did was really make it just easy to install. It just became really easy to set up a single process, deploy it anywhere. Since this came out, it has gained a ton of attention for different use cases. I think when we built it, we thought it would be really useful for Edge, potentially for CI, but we've also seen a lot of demand for people using it as a desktop development environment. So we're seeing people use, there's a project called K3D, if you want to take a look, which is kind of K3S with Docker, that has become pretty popular just since we rolled this out. The K3S project is still pretty early in its life. It's an alpha project. We introduced it in March, where we've already implemented support for it in Rancher, but over the next 6 months or so, we're working on a lot of additional features, and you'll see this kind of graduate to GA, probably before the end of this year, sometime in the fall. The big thing that happened with K3S though is it really started a conversation that has taken off around what is the future of Kubernetes really look like? Is Kubernetes potentially going to be a unifying force for how we run containers? I mean, from its beginning, Kubernetes was always modeled on Borg from Google, right? A really big distributed system that could run massive amounts of workloads optimally, and its natural location was kind of the data center. But what we see today is cloud providers are offering Kubernetes as a service, so you can easily get a Kubernetes endpoint from really anybody that offers cloud. I think AWS, Google, and Amazon are obvious, but DigitalOcean, Ali Cloud, Oracle Cloud, they all are offering Kubernetes services. And so you can easily get a Kubernetes endpoint in the cloud. And now because of that, the implementations for getting Kubernetes on your desktop have gotten better and better, right? With Docker for Mac and Windows support for Kubernetes, Minikube, K3D. Like, there's a lot of ways to implement there. So now, the interesting question is, will it kind of penetrate to, the other parts of IT, we say branch, factories and shops and retail locations. We see a lot of interest there as people want to, kind of push multiple clusters, clusters out into locations where they already run applications and services, but now want to be able to manage them more efficiently. But even equally interestingly is the potential for, single node Kubernetes to end up on things like ATM machines and MRI machines and wind turbines and cash registers and pretty much anywhere you can imagine Windows or Linux running today, set-top boxes, people are talking about. You could imagine Kubernetes, a single node Kubernetes running. And the real question is why? Like, well, what value does Kubernetes add? And what's cool is when you think about it, it actually adds a ton of value. If you have Kubernetes in all these places, you get a lot of consistent functionality that goes beyond what you would get with Windows, right? One, you get a consistent API for deploying applications. You get RBAC and access control on these devices to define who can access them and what can run on them. You get a lot of capabilities around resiliency, like health checks and HA and traffic load balancing. You get to deploy workloads and do workload migration pretty easily. You have the ability to use all the storage capabilities to do things like backup and recovery of data. There's great monitoring capabilities around Kubernetes, so you can leverage Prometheus, Istio, things like that if you want to get into more complex application management. And just out of the box, things like service discovery and networking, storage drivers are all bundled in. So you get this really rich set of functionality that on thought makes sense kind of everywhere. And in fact, when it gets everywhere, there's some pretty major benefits, right? And once you're using Kubernetes across more systems and more workloads, you can get some really big business benefits. You're talking about now, having the ability to consistently deliver a great application experience in all of these systems, right? Failovers and clustering of nodes if you have multiple nodes, the ability to do deployments and DevOps, in a very efficient way with a standardized set of automation, right? I understand the API I'm going to be talking to. I know what kind of capabilities there. I don't have to tweak that or modify that because I'm going to have the same, runtime capabilities wherever I'm deploying my containers. And then, maybe the most important thing is that once you have this consistency, you can actually start to enforce security policies everywhere, and you can start to define what's allowed to run, what services are allowed to talk to one another, how to control access, and how to even whitelist code that's allowed to be deployed on specific nodes in a broad network. So there's a pretty strong case that for us to get to the level of security we've been talking about for a long time and avoid these hacks that tend to come in from the periphery and the edge. What we need is better operational processes that are consistent, and taking all the investment we're making in security in the data center and pushing it out everywhere else. So this becomes the interesting opportunity is as we move forward, Kubernetes could very well be on. We could be talking about not managing a Kubernetes cluster or a dozen Kubernetes clusters. We could be talking about managing hundreds or thousands, or in the case of things like set-top boxes and ATMs, potentially even millions of Kubernetes endpoints, all of which need to be, managed consistently in a consistent way. So it's an interesting challenge. And when you dive into what's actually running on even a single node host, really the stack that we're talking about is pretty predictable, right? I mean, every machine, whether it's, anywhere we would run this, we would have the operating system, some type of container runtime, whether that's Docker, or Containerd, or CRI-O, or Kata containers, some runtime for the containers, and then Kubernetes runtime, the kubelet, and the Kubernetes control plane. And if it's not, if it's not just a worker, like in a single node, you'd have the control plane running there. So so we kind of have this known set of technology that'll be there, and then whatever workloads we run on top of that will be containerized and run within it. And so if you think about what K3S rolled out, one of the things that made K3S so easy to deploy was that it consolidated the runtime for both, the container runtime in the case of Containerd with the Kubernetes runtime and the Kubernetes control plane into a single, atomic unit that would run on any Linux. And that's really important. It would give us, consistent way to go anywhere. And so when we started looking at this, it kind of begged the question of, well, if we're going to do that, what could we extend some of this consistent management that K3OS is going to give us down to Linux? And so what we were looking at with k3OS was, was it possible to kind of, again, shrink the OS footprint down to include just what was necessary to run Kubernetes, so that we could minimize the attack surface and optimize for, for the workload. We wanted to, if we were going to do this, we wanted to integrate the management process so that Kubernetes, Linux, and the container runtime were all part of kind of a single atomic unit that could be managed consistently, and we could, with one command, effectively upgrade everything, right? Apply patches to everything within there, define, the, sort of tested and validated stacks that would be rolled out and then upgraded as almost like a unit. We were certainly, conscious that there was demand to continue to focus on scale and size and keep the OS as small as possible. So, especially for these edge nodes, we wanted to really utilize as little disk and RAM as possible on the machine. And then finally, we had already done a lot of work in this area with RancherOS, which has been around for a couple of years now. It is a popular distro for running an OS where Docker is sort of the runtime. But because that was all really built around Docker, and we were moving to focus on Containerd as the runtime for K3S, it really didn't make a lot of sense to leverage RancherOS. We wanted to, we didn't want to have the footprint of Docker and the footprint of Containerd in the same node. And so, we really thought it was worth, kind of asking the question, what would be the right architecture? Because what we really wanted to get to is we wanted to enable teams to have really just a single atomic unit that would include basically the Linux kernel, a full Linux distro, and the Kubernetes implementation. And that's what we've built with k3OS. It's an operating system that's really purpose-built to run K3S and run Kubernetes. But by being a purpose-built operating system, we can orient it towards exactly the requirements we had and focus on it being something we could easily manage from within Kubernetes. So K3OS hits a couple of really key bullets. It is just enough Linux to run K3S. It's a very small footprint operating system. Darren will get into the details there. That means it can boot incredibly quickly. We can boot these up in seconds and easily have them, join an existing cluster or create a new cluster. We base the whole thing on the Ubuntu kernel, so all of the drivers and everything that are in Ubuntu will work. It really kind of solves a lot of the hardware challenges. And we integrated the management of K3OS with K3S, meaning that when you launch K3OS, it automatically instantiates K3S, and depending on from K3S, if you provide, there's an operator framework built in there so that when you do things like upgrades, you can define exactly, not just what version of Kubernetes, but what version of kernel you want implemented on the host. And so an upgrade of K3S includes an upgrade of the kernel. The current release supports x86, but we'll be supporting ARM64 and ARM-v7 in the next release or so. So expect that in the coming months. And the project is still pretty new. It's an open source project, as everything we build is. It's not yet a Rancher product. It's not available for support or anything like that. But it really is built with production in mind. So like K3S, it's not meant to be used for just dev environments, but really designed for production scale deployments and with production management expectations. So a lot of the work on operations really is geared around managing fleets of these things out there. So with that, I'll stop for a second, and if there's any questions, Darren, that you wanted me to jump into, I can. Otherwise, we can start the demo now.
No, if I was going into the demo.
Okay, great. Why don't I pass over the controls to you, and you can share your screen.
All right. Let's see. Show my screen. Okay. You should be see. Cool. All right. So let's go into the demo. Oops. There we go. So just kind of what I'm going to do. I'm going to be demoing quite a bit. I'm going to start off just kind of talking about the status of the project, what we're currently developing, working on, go through kind of a quick start, just how you can get like K3OS running on your like laptop, and I'm going to use VirtualBox, works the same in VMware or KVM. Talk a little bit about how the configuration works, so you understand how to configure the OS, and then start going through like a multi-node setup on AWS. And that one will go more in detail, build up a larger cluster, use some of the configuration, kind of show how this all works end to end. I'm like really excited to demo this stuff because I really, it's like I'm really excited about K3OS because it's kind of it's just further completing kind of the stack of what we can kind of offer like from Rancher. We have the management, we have this awesome, lightweight, easy to run Kubernetes distribution with K3S. Now we can do the OS too and manage it all. So I'm going to demo kind of the whole vision of kind of what we're trying to do with these technologies and how to piece it all together. And then after that, I'm going to get into some of the internals, and this will be some of the lower level guts of what we did, like what makes kind of K3OS somewhat unique or different, or the same as other distributions. And then at the end, talk about kind of the different installation modes, because as I get into the internals, I'll talk a lot more about kind of the goals of what we're trying to do. And when we get down to, kind of the function of, what we actually have to do as providing a distribution, it's a significant amount of just trying to package up the OS for different platforms. So there's a lot of different ways to get K3OS installed onto your devices. All right. So the current status, so Shannon's already talked somewhat about this, but basically this is an alpha. We like to release things, kind of early. So this is, it is an alpha. We're kind of working towards a beta over the next couple months. We think over probably the next 2 months, or hopefully faster, we'll get most of the functionality of what we would say would be a beta, but then working through some bugs, and then hopefully we can start kind of a beta period and start marching towards GA. But so what's currently already done with the OS is kind of like the base OS is there. You can install it and you can configure it. Like the installation configuration system is all, it's pretty good at this point. We're shipping right now kind of a full distribution for x86 and ARM64. So that means we have like the user space, the kernel, we produce an ISO with a bootloader and the installation, so we can kind of do the whole end-to-end management of these two platforms, Intel and ARM64. And both of these right now I have also like running kind of in cloud environments. For ARM v7 right now we just have the user space done. So ARM v7 is kind of a whole different realm. We're not going to support anything older than v7, so any like v6 stuff, there's just not enough support in the Kubernetes ecosystem for it. So we're basically kind of cutting the line at v7. So it means like, you're not going to see images for like a Raspberry Pi 0. Those chips are just too old and not enough support from the ecosystem. But so like right now for the ARM v7, we have just user space available, which means like you could actually just take, and I'll go into this when we go into the installation and the internals, you can just take the user space and just replace that on any ARM image that you might already have. But the problem with the ARM v7 is just supporting all the various kernels and bootloaders. So we have a plan. So that's kind of like the next phase. So these are the things that are in progress. Is we're currently working on getting all the cloud images available. So right now we're not publishing any AMIs or anything for Google, Azure, or whatever. We have support for those clouds. Like if you know how to set up an image and boot them. Azure is the only major cloud that we don't, but we are working on that. We will have Azure support. But like Google, Amazon, I don't know, Packet, DigitalOcean, those should all work. Anything that has like kind of a standard AWS style cloud config or a CD-ROM based one, any of those will work if you know how to set up, build cloud images. But we're working on, doing that. We'll push official and maintain official images. The next is the ARM images, and that's largely for the ARM v7. So there's just all these different boards that we want to support. There's actually an issue in GitHub if you want your specific board. There's an issue that I opened up that just says, what boards do people want supported? Just go in there and kind of vote for your board, so we know which ones to target first. And then the last thing that we're working on, not in this order, actually, this is not like this. The Kubernetes is the Kubernetes operator. So like that one is actually really high priority. So that one should hopefully we'll be rolling out in the next 2 weeks. So what the Kubernetes operator is that's the integration of K3OS with Kubernetes. So right now you can install K3OS, but you can't upgrade it because the upgrade is actually managed by the operator. It's not you can manually do it, and I'll show you how that works under the hood, but it's really the operator that's going to manage the OS and upgrade. And so I'll show how the operator works and how the data structures and how you would manage the cluster, but that's not released yet. That's still in development. Okay, so I just wanted to kind of, before I got into this, is just kind of point out, because really we're using so much from the community, there's so many other good projects that have come before us, and so it's in K3OS we're using the Ubuntu LTS kernel. We're not really kind of attached to a kernel for K3OS. It's we're very agnostic to a kernel. So the Ubuntu one is just a good generic kernel. It works on a lot of things. Canonical does a great job of maintaining that. And so right now we're using that kernel. When it comes to the ARM v7 platforms, for those things, a lot of them we're using custom kernels that are coming from vendors and whatnot. So we're not heavily tied to a kernel. We can package all different types of kernel. Again, when we get to the internals, I'll show how that works. For the user space, this is a micro distribution tailored toward Kubernetes, so you're really not doing a lot on the host. You're not really logging in and doing much. We really wanted and when we built RancherOS, we did a busy box thing and we built everything ourselves. There's kind of no reason to reinvent the wheel. Well, we use Buildroot, which is a great framework, but at this point, it was just significantly easier to just pick up Alpine. They do a great job of packaging things. Linux Kit has had good success with using Alpine, and so basically the user space is Alpine binary. So when I get into the internals, I'll show how it's actually built. So the system is based on OpenRC. This is actually the first time when I started building this, I really heavily started using OpenRC. Huge fan of it. It's very nice. Does its job well, and it's very simple. And then Linux Kit, we're using some of the libraries. We didn't actually use Linux Kit to build K3OS. I really wanted to. I tried to, but we just ended up using a bunch of libraries from Linux Kit. And then kind of things we've taken inspiration for, CoreOS was really one who kind of started this idea of the container distribution. They had so many great ideas. RancherOS was something we built ourselves. I think one of the obvious questions that always comes up is K3OS a replacement for RancherOS? Are you going to continue to support it? I'm not quite sure if Shannon actually covered this. So RancherOS is very, very tailored towards Docker, and it's kind of core to what it is it's a thing to run Docker. And the configuration, everything is oriented towards that. So K3OS is very oriented towards Kubernetes, and we really think they're two different products. We're not sunsetting or replacing RancherOS. RancherOS will continue forward, and then K3OS will kind of be, what we'll be targeting primarily for the Kubernetes clusters. And the last thing is Ubuntu Core. There's just been they've been a lot of work and a lot of interesting ideas of how they've packaged up that distribution. Okay, so now let's get into actually demoing. So what I'm going to do is I'm just going to start off with just showing, this is just kind of like the quick start. Is hey, I just want to download it and run it real quick and see it. So the where you can get K3OS is just go to our GitHub. So it's just Rancher K3OS. Sorry. And then go to releases here. And so 0.20 is the latest. I just did this one. You can see 10 hours ago. Just did it last night. And you can see all the assets that are available here. So the ISOs, you're just going to want to download the ISO. So one little note, you'll see it's about 400 megabytes. So this one is a little painful for me. When we did RancherOS, RancherOS started at 20 megabytes and then slowly over time ballooned up to like maybe 150, 180 megabytes. When we started K3OS, we kind of decided we're not going to shoot for super small because it's too hard to shoot for super small because in terms of the disk footprint, because really what that means is just dropping drivers. Because out of that 400 megabytes, you'd be surprised, 300 megabytes of that 400 is the Linux kernel. And that's a compressed size too. So that's the kernel, all the kernel modules and the firmware. So we really wanted K3OS to just kind of work anywhere. So because of that, we decided we're just going to go kind of package the whole kernel. So that's why it is 400 megabytes. Which is it's mind blowing to me, coming from the days of, OSs fitting on floppies, but that's just what Linux is now. The core Linux kernel is still about 8 megabytes. It's just all the drivers, the kernel modules and firmware and stuff just is ballooned like crazy. Okay, so there's a lot of different things here. When I get into the internals, talking about that, this will make more sense what all these other files are, but if you just want to get going real quick, just download the ISO. So I already have the ISO available. We're just going to boot this up in VirtualBox. This will work, basically any hypervisor, VMware, KVM, Hyper-V, whatever. And we out of the box support UEFI and BIOS, so DOS partition or GPT. So if you're running the live distribution, I kind of say just start with 2 gig. So if you just want to install this or you're running a very minimal system, so like the smallest requirement for K3OS is 512 megabytes for a worker node. You can also run the master in 512, but it's basically going to consume all the memory. So like a master, I would say the minimum you probably want probably a gig. But since we're going to be booting the CD-ROM and running a live mode, that means that all the user space and so even the kernel when it's extracted is 700 megabytes. So it's so for a live installation, you just start with 2 gig. But if you actually install it to disk, what I'm saying is you can use significantly less memory. None of this stuff really matters. It's kind of all the defaults. Okay, so we're gonna start this up, and then it should ask for the ISO. Yeah. Okay. So. So this is gonna boot. So again, this is booting a live installation. So it's just running off of memory. It's not touching the disk. And so this is going to boot up the full OS. So when it comes up, it says login with the user Rancher. In general, K3OS, this is also how we did RancherOS. For the most part, in general, it's like a single user operating system. You can put in multiple SSH keys or whatever, so multiple people can log in, but there's just not a huge reason to have multiple user accounts on this because it's like an appliance. Why are multiple people coming in and looking at this? So it's for the most part, we just have one user. So it is technically feasible to add other users, but we just don't really see much point. So it's we just set up the Rancher user, and that's primarily what you're going to be using. So when you log in, it gives you this little message. And the last thing you'll see at the bottom, it says you can configure this system or install to disk using sudo osconfig. So this is just a little, effectively a little script to just kind of help you install, to do an interactive installation. Before we actually run through the installation, I'll show you, this booted up, we're already running, actually, go back to the tree view. We're already running Kubernetes. You can see the containerd processes over here. So if I just say get all namespaces. So the Kubernetes is already booted up. I've got a ingress controller and service load balancer. 404 actually means it's running because there's no applications, but it did hit the ingress. So so basically, when it boots, you already have Kubernetes. Kubernetes is already up and running. Yeah, there's really so this just comes up as a single node cluster. So a lot of that, that's just kind of what K3S does. So now let's actually run through the interactive installation. So if I do sudo osconfig, so it's going to ask you, do you want to install the disk or configure a server and agent? So this is a live setup. So what I could do is I could launch another VM using the ISO and then say, okay, I want to configure this as an agent. I want to configure it as an agent here. And then it will ask you, well, what's the URL of the server? You enter that, and then it'll ask you what's the token. And so that will then join another server, and form a cluster. But this is all interactive. This is not how you'd really kind of do it in production. This is just to like demo and try it out, just fool around with it. So I'll show you like the actual like scripted installation and stuff like that. So let me start it again. We're going to install the disk. So it's going to ask you here if you want to configure the system with a cloud init file. So the cloud init file is how we configure the whole thing. I'll talk about that in just a second. So if you have a cloud init file, you can give it to it at this point. It will just ask for the URL or if it's on disk, and then it will install and reboot because the whole configuration comes from the cloud init file. So if you don't have one, so I'll start it again. Sorry, if you don't have a cloud init file, then basically it's going to ask you a bunch of questions to effectively generate that file. So it's like, do you want to authorize any GitHub users from SSH? So it's like I can just give like my account on GitHub. This will install the SSH keys from GitHub, or the authorized keys. It's not the private keys, it's just the public keys. Do you want to configure any Wi-Fi? So yeah, out of the box we have support for Wi-Fi. Let me see. I've really just tried this on the Raspberry Pi right now, but yeah. So under the hood for networking, we're using Conman. So Conman does a great job of managing networking and kind of all these weird edge use cases. So if here you can say, do you want to configure it? I'm not going to configure Wi-Fi. I don't have any. Do you want this system to run as a server or an agent? We'll just stick with a server. At this point, it asks you if you want a token, enter a token or a cluster secret. So when you're forming a cluster, there's two modes of how to form a cluster. You can first, you can launch the server and the server generates a node token, and then you use that node token and you give it to the nodes. Or you can ahead of time just choose a cluster secret, which is just some random value you pick. So the cluster secret approach is typically easier to automate. So here would be the point where you type in the cluster secret. I'm not going to use one. So then finally, it's just going to ask, do you want to install the disk? So without all the talking, the installation, you can just run through that in a couple seconds. So you see, so it installed to disk, and then it's going to reboot, reboot, and then we should have, let's see, it's booting from the CD still. Do I have to remove the CD? Let's see, storage. What the heck? How do you remove the CD? Oh, remove disk. Hopefully this works. Usually it just boots off the disk. I wonder if the installation actually failed. Oh no, the installation worked. I don't know why it booted off the CD that second time. Typically, like it'll just boot it'll just boot the first disk. But anyways, okay. So it's asking for the current, previous, or a rescue shell. So like we actually keep all of the, like quite a few versions of k3OS available, but the bootloader we just kind of hard code to like what's the current and previous. There is actually no previous right now, just current, because there's only one version we've ever installed. Close that thing. Stupid messages. Okay. All right, so booting up. So the first boot takes us slightly longer because it expands the hard disk. So that's just something to make it easier to build, images that, Wait, did I ever? Oh shoot. Well, I put in the SSH key. Okay, so when we did the installation, it said, well, what do you want to authorize GitHub users? So it put in the SSH key. It didn't ask me for a password. So now I feel like an idiot. Okay, let me just do it like super fast again and enter a password. Sorry, this won't take long. I don't care. Oops. Okay, start. Yep. Okay. Well, at least you get to see how fast you can do it if you know what you're doing. Okay, Rancher sudo os config. Yes, we want to install. See here, like when I said, if you say no to the keys, then it asks you for a password. So I'm just going to put in a dumb password. No, keep it as a server, install the disk. Okay, let's see if this time it works better.
Hey, Darren, can you expand the size of the console a little bit just to make it easier to see?
Oh, well, okay, so I don't think I can, let me see if, can I do it with this one? No, see the VirtualBox doesn't like, I don't think it like, does it? Is there a way to?
Okay.
When I do like console-based stuff, I can definitely, okay, let me eject the CD again. Oh, I think I can just do it from here. Well, okay.
It's fine, it's okay. It's totally, it's just a little bit small to see, but I think
yeah, sorry, it's just, okay, let me remove that disk and I'll boot up. I wonder if there's like an option here for scaled mode. Oh yeah, so now it can be really ugly. Look at that. Okay. Okay, so now we're booting up here. Yeah, there's a message that's starting light. So the system typically boots in about 10 seconds. Like raw boot speed is not super important for us. You know, we just want to keep it reasonable. You know, if optimize too much, and the system becomes kind of complicated. Okay, so I'm logged in now. So again, if I just go and just run this, you'll see Kubernetes we just got a single node cluster, you know, running here. So containers creating, it's coming up. Okay, so now, so that's just kind of how you can install. Let me talk a little bit about the configuration. And at the end, we'll talk about automating the installation. But let me talk a little bit about how the configuration works. So first, I think before we get into important to understanding the configuration is understanding the kind of the file system. So all the docs right now are just in the GitHub repo in the README. You know, we're doing our best to put all, you know, as much as we can in here. There's quite a bit of info. It's pretty dense, I would say. You know, like a lot of info in a small amount. But okay, so let's go to the kind of design system or design here. So this is the file system that you're going to see on disk. Like it's just, you know, for the most part, a Linux file system. But the key thing here is etc is ephemeral. Every single time we reboot the system, the etc directory goes away. So we very much did this on purpose. There's no persistence of the configuration. The reason why is all the configuration needs to come from the cloud config file or the cloud init file. So etc is ephemeral. The user, this is read-only. You can't write anything to it except for user local is writable, but user local is effectively just a symlink to var local. K3OS is the system files. When we get into the internals, I'll talk to you about the system files and how that's really how the OS is managed and the upgrade and whatnot. So then all these other directories are basically persistent. For the most part, the way it works is the root is actually persistent, and then we mount USR is read-only. We mount in the system files, and then we set up a tempfs for ephemeral. So technically, any other directory is also persistent, but these are the ones that like we really want you to use because we might restrict it down further that you can't have like some other random directories. This is, you know, so the important thing is like we really want to keep these two things is that the core OS is read-only, like the binaries and whatnot, you can't change them. They're actually in a squashfs image. So they're read-only, and then all of the configuration is ephemeral. Okay, so that means, well, where's the configuration actually stored? So that's when we get into configuration here. So configuration is actually stored in these files. So if I go back and I look at my VM, so in the K3OS, so let me go to the root here. So you can see here, so you can see that the K3OS directory, the mounts, yeah, it's kind of garbage because I've got all the containerd stuff in here. So if I go into K3OS system, so you see there's a config YAML in here. So that's just, so like when I did the installation, the interactive installation, it was just generating this file. So the only thing that I put in there was, well, what's the password? So my password is in there. This file is only readable by root. But in general, we wouldn't recommend putting a password. Use SSH keys, significantly better. The password is just for like interactive stuff, but you should really be using SSH keys, and then also manage them through the operator. When I get to that, I'll show you that. Okay, so the configuration is it is first, there's a file here. This is the system configuration. This is kind of like, so like this file is actually read-only, I believe. Let me see, because the K3OS, that file system is read-only also. So like you can't actually edit that. So this K3OS system config YAML, this one is kind of like the baked-in configuration. So this is kind of like OEM provider-specific configuration. This is where, like, if I'm packaging this for AWS or Packet and the system has to be configured a certain way for that environment, you're going to put it into this file. So this file is typically created during the authoring, like the installation or authoring of the image. So it's not the one you change like after the fact for the user. So if I wanted to change any configuration specific to the system, then I would change this file. So this file by default doesn't exist on a brand new system. The config directory is not even there. But this, or the, so the config files aren't even there. So this would be the file that you would change for the local system. And then additionally, you can put whatever fragments you want in here, and then we merge it all together into one like rendered config. So additionally, besides these three files, the configuration can come from kernel, the kernel command line. So that's even like if you want to put configuration that is going to be needed before you even touch the disk. So like initRD, like something that's going to change the way it works in the initRD, like that can be done through the kernel parameters. Actually, anything that's in the cloud config, I'll go through this stuff in a second. Anything that's in the cloud config can be configured also from the kernel command line. So besides the kernel command line, it is also pulled from the cloud data sources. So that's like the user data from your cloud system. So AWS or Google or whatever user data support, it'll be pulled from that too. The only thing that's important to know about that is that is pulled after networking is available. So that's later in the boot process. Okay, so looking through, so this is actually comprehensive, this example here of everything that can be set. If you go to the configuration reference, we go into details talking about each one, but I'll quickly go through these things. So this is just basically, this is for cloud setup for what data sources I'm using. Unless you're building images, if you're building images, then you're going to want to set that up. If you're using prepackaged images for the environment, then you're never going to really touch this or see this. This is what authorized keys. This is write files. So this is, write these files on disk. So this is actually kind of the primary way you're going to do a lot of configuration. If you're doing, there's not like a huge amount you really need to configure with K3OS, but if you want to do something, I don't know, like if there's something like RAID setup or something with iSCSI or, networking specific routes and whatnot, a lot of times basically you write a file to disk and then you say run command and you run the file that you wrote. So you can just run, some script on startup. So you can basically customize a heck of a lot of things that way because you're just writing a shell script. So what's the host name of the system? Typically it's coming from DHCP, but if you don't have that, then you can just set that. These keys here are actually kind of standard cloud config fields that comes from like the standard cloud init. And then the K3OS is specific to K3OS. If it's not documented here, we don't support it. So like we don't have support for a significant amount of the fields because they just don't make sense. Of like, obviously you're not going to install RPM packages or whatever. So there's a significant amount of things that are not in there. So this is the stuff that's specific to us. This is any modules that you want loaded on boot. Most modules, just auto load, but some of them you might, for whatever reason, like KVM Intel or something, sometimes you might need to do that if you're doing VMs. Any sys control parameters you want set. DNS. So DNS, these are really like the fallback DNS name servers. Like Conman is going to try to set up DNS based off of your DHCP. That's kind of the preferred way to do it if you don't have DHCP. Then this is what I'll fall back to. There is no other network configuration in here because this is all we do for networking. This is like the very basic primitive things of like DNS and NTP servers. Anything else for configuration, you're basically, for networking, you're just going to have to write a conman service file. So you use the write files directive to write a conman file. Conman service file. They're really simple. They're really straightforward. But then you can do anything you want with the networking. That's when you get into more complicated networking. We didn't see much point in like trying to cover all these cases. Like we did it in RancherOS, and we had like our own syntax for like setting up bridges and VLANs, and it's just like there's so many configurations that it just kind of gets silly. So like the basic things, because like for a lot of people, they're just using DHCP with a single interface going out, and it's like Conman will just set that up fine.
Darren, so, Conman, is that an open source project that people can find easily? Because somebody asked what that was exactly.
Yeah, sorry, this is an Intel project. So Intel built this. They built this for kind of like IoT embedded. So you can just go, if you just Google Conman, CONNMON, it's from the Intel, like 01.org is Intel's open source stuff. And then really all of their docs are pretty much in like the man page. So you almost end up doing better if, where's man? Because like you can just a lot of times just say man conman. Yeah, so most of their docs are in the conman stuff. So I'll show you here. And right. So basically you're going to be writing one of these, and it's kind of similar to like systemd configuration, like INI file style. And so they have a bunch of examples here, how to set up like various like Wi-Fi or Ethernet, different name servers. And so you can just configure everything through that. So you just do a write file, you put this stuff, and it just goes to var lib conman blah. Okay, like that can be anything you want. Okay. Yeah. Okay. So going back here. So, but we did put Wi-Fi because this came up so often when we were testing ARM devices, because it was like there's so many ARM devices where it's like, well, I really just want Wi-Fi to work on boot, and it was always the same thing of just SSID and the passphrase. So for Wi-Fi, that's the one kind of networking thing that we kind of did. Again, it's just a basic. This will set up what a WPA, right? So this will just set up like the kind of common networking or the common WPA Wi-Fi. If you want to do something more advanced, like the enterprise stuff, EAP, like this type of stuff, then you're gonna have to fall back to a conman service file. But it does work. Okay, so this is if you want to set the password for the user, you can either put a regular Rancher user or clear text or an encrypted form. The easiest way to get it from a encrypted form is just go to a Linux system, set a password, then look at the etc shadow and copy the value. So this is where we start getting into K3S configuration. So this will configure the K3S on the system. So this is the server you want to join. This is the node token to join the server. These are any labels that you want set on this node when it registers, and also any taints that you want. So these are important when you're setting up a more complex environment, you want like dedicated nodes for certain things, or you just want to tag them for different reasons. So you can set those. Any arguments that you want to pass to K3S. And then finally, any environment variables that you want to pass to. So like if you want to do proxy, this is where you're going to put it if you need to support proxy. So K3S, we've been, I think we're pretty good now on K3S that it works behind a proxy. I don't know of any known issues, but we've been working through those, trying to make it easier and easier. So hopefully K3S, I imagine we're going to have similar, kind of random issues. So please, people with corporate proxies, try it out. We do test things behind a proxy, but we just don't end up trying all the different use cases or different types of configurations. So that's always a tricky one, those proxies. Okay, so that's the whole configuration. So it's like everything for the OS is defined by this one file. Okay, so basically, in order for me to configure k3OS, I just need to have this cloud config file. So now this is where the Kubernetes operator comes in. And so as I said before, this is still in development. It should be coming pretty soon. So this is like not like far off. I mean, I honestly should have had it done this week, but just didn't get it in. But so I wanted to show you kind of how this is going to work. So the operator has basically two data structures you mostly care about. First is going to be the cluster. So this is a cluster config. So when you run k3OS, k3OS will automatically install this k3OS controller in the cluster that it's in. And then this controller can start configuring the system. You just have to interact with it through kubectl. So in here we manage the versions of three different things. These are kind of independent. Is we have the version of k3s. So k3s, if there's a new version of k3s, we can just download that, restart it, and run the new version of k3s. So there's the version of k3OS, which is kind of technically this is really the k3OS user space. And then there's the kernel. Because as I was saying before, like we're not closely tied to the kernel. So we manage these as three separate units. So each one of these can have you can either pin the version directly. You can say, okay, I want 020, or you can set so that's like this example down here for the kernel. It's like, I want to have it pinned to this version. My policy is manual. I'm not going to have it auto rollout. If you wanted to, you can instead say the upgrade policy is auto, and then you point it to what URL to check for releases. So we'll have like a stable, it's like a stable beta and development channels. So the way that all of these rollouts happen is like we're managing. So it's like if we were upgrading K3S, for example, K3S, like that's changing the control plane. So like a K3S, we look at the versions, the nodes can't be newer than the control plane. So we're going to upgrade the control plane first. So we roll out the upgrade across the nodes, make sure that the upgrade succeeds on each one. Once the whole control plane's upgraded, then we start upgrading the nodes, and then we start rolling out the upgrade on the nodes. OS is very similar. I mean, so when we do a K3S, we don't actually have to reboot the box. We just reboot K3S. So it's fairly seamless when you're just upgrading K3S. When you're doing an OS, the OS or the kernel, we actually have to reboot the entire box. So those ones, we roll those out across the nodes. So same thing. We upgrade it, reboot them as we need to. So this is all the version management. And then we have the config. So this config field, the structure of this config field is exactly the same as this config. So like here you see SSH authorized keys, here I have SSH authorized keys. So any configuration you put here in the cluster config will be applied to all nodes. Every single node in the box is going to end up with this configuration. So you can have a cluster-wide configuration, so everything gets configured according to this node. Obviously, you can have situations where you want nodes to be configured differently, so that's where the node data structure comes in. So we have another, here, oops, let me close both those. Okay, so before I get into the node one, let me just talk about this a little further. So the idea here is that with the Kubernetes operator, the k3OS, kind of operator for that runs in Kubernetes, is the operator should be able to fully manage the OS, the configuration of the OS, everything. So when it comes down to it, it's like once you set this up, kind of the idea is when you join nodes to the cluster, you don't really give them so much of a configuration. You just pretty much join the node to the cluster, because then it will then adopt the configuration of however it's set up in Kubernetes. Okay, so now we get to the node configuration. Okay, so the node configuration, so the key thing here is we now have a selector for the node configuration. So what I was showing you in the cloud config, that was the configuration that was like global to the whole cluster. But for whatever reason, you might want to have configuration that's different per node. So this is where you just define a selector and say, okay, I want to match these nodes with the selector, and this configuration will apply. So besides the selector, all fields in here are the same as the cluster config. So for example, like one of the cool things you could do is you can set up one node in your cluster that's kind of like the canary for the kernel. And just set that one to auto, like it all auto upgrades. So it's like that one node is always on the latest kernel. So like, you want to be more reserved across the whole board, but like that one is, is running fine. So it's like you can set the upgrade policy and the specific versions. So, if you have like, let's say these nodes are dedicated to persistent workloads, and those ones you want to manage a little, more like a pet, you can do that with the selectors. So you can basically manage like these other nodes, completely ephemeral, I don't care, they just auto roll out. If they die, not a big deal. But these specific nodes, treat them more special. And then you can also do things like, this is where you might do something where, for the storage nodes here, I'm actually looking for a specific like block device and setting up the storage and doing whatever. So you can configure those nodes. So basically with these two pretty basic data structures, you can manage the whole cluster and have a good amount of control over what's going on. I think I'll stop there just to see if there's any questions.
There's all sorts of questions. I've been kind of holding a whole bunch of them for a while. One question was, just as you get this running, if you could show any kind of CPU load metrics and kind of get a feel for how much CPU or RAM are being used, would be helpful.
Sure. Let me see. Like, most people don't believe me. This is actually the default configuration up top, like how it's red and ugly. Distributions always tweak this, but we have not tweaked this, and it's red and ugly. Okay. So you can see, yeah, you can't actually. Let me get a better memory. Free used. This is gigabytes. So right now, so this is a single node cluster. Let me just run the free command to be a little more obvious. So basically, this is a single node cluster. It's using 261 megabytes of RAM. Basically, it's kind of like K3S. We typically say like starts for a single node cluster, like to the control plane with the agent. We typically say that it starts around 250 megabytes. So what you're seeing here is the OS itself is about 20 megabytes of memory. And then it's whatever the K3S adds on top of it. So we're not like down to like super micro sizes. Like it's going to be a little hard with Go to get like just super, super small. But we're under like we're in the realm of, this will work on like smaller ARM devices. And if you're just running a node, then the base footprint is like 100 megabytes less for just like a node that doesn't have the control plane on it.
Another question.
CPU, so CPU, this is virtual, so it's gonna, I don't know, but right now, basically, like just to give you some idea, is like, I'm pretty sure if you run this on a Raspberry Pi, when it's idle, it's gonna be consuming almost a full core. This is something we're looking into of trying to see if we can get that down even further, but Kubernetes, when it's sitting there doing nothing, does a lot still. So like, you still have got 3 cores left. Like a Raspberry Pi is like, I'm talking about a Raspberry Pi 3. Those are 4 cores or 4 threads. I don't know how many cores, but it typically shows, I believe it's 4. And so you have like 1, because it will say the CPU usage is usually around like 20%.
Another question came in. Omar was asking, can you switch out the container runtimes to use CRI-O or something else on the worker nodes or any of the nodes, maybe?
At this point, so for K3S, you for sure can. K3OS, I'm not sure if we're really going to support that, because the K3OS, is kind of a more locked down in terms of what you can install on the system, because the user directory is read only. So the only way you could do that is you have to create these OEM overlay and package up it specifically for K3S. So we don't, right now we don't really foresee supporting that. It's kind of at that point, maybe you should just use Ubuntu. So we will have support for Kata containers at some point. That's important to us, but we don't really, I don't know, I'm kind of curious. The only thing I've heard of why people really want to run CRI-O over containerd is the SE Linux support. So I've been, trying to push on containerd, the containerd CRA implementation to improve the SE Linux support. Because honestly, I would like to support SE Linux and K3OS, just the SE Linux where each container runs in a different context. So yeah, so I don't foresee us really from a lot of the kind of the guts below the runtime of making it super configurable. You probably just want to run your own distribution, or more generic distribution at that point.
Let's see. There's a question.
But sorry, I just wanted to call out. So that specifically applies to the container runtime, but things like storage and networking are very configurable. Those can come in because most of the storage and networking solutions that come with Kubernetes these days are deployed through Kubernetes as containers. And this is actually something really exciting for us, is that we can make these things work. It's something that's using the kernel. Let's say like Cilium is a great project. We can make sure that works great on K3OS. It's perfectly tuned for it. So some of these storage and networking is we're really hoping, to, kind of build some partnerships in that area and have some really cool optimized solutions there.
Okay. There was a question. Herman had asked if we could show an example of a really small, minimal requirement for configuring K3OS, just what a minimal config.yaml would look like to boot something up.
Oh, well, that's basically what I have here. This is a minimal, is basically just a password. And if you don't want to do a password, then the other one would be, SSH authorized keys. Just give an SSH key. So you can put the actual base64 key in here, or you can pull it from GitHub as long as you're gonna have networking when it boots. That's the minimal. That's all you need to basically boot up a system. You just need some credential to get in. And honestly, if this is a worker node, you don't even need credentials. So that one, all you then need, if it's just a regular node, you're just going to put in whatever the server is. It always runs at almost always runs at 6443, and then you put in whatever the node token is, and that's going to join it to the cluster. So that would be a minimal configuration, joins it to the cluster, and then based off of the Kubernetes operator, it can apply any more configuration that you need, like SSH keys and whatnot. So that's the minimal. And I'm going to show this in just a second as I get into I'm going to do a kind of a more extensive demo on Amazon.
There's a whole bunch more questions, Darren, but why don't you jump into the rest of the demo and I'll answer some and we can roll back to anything else.
Okay, well, I'm going to leave this one running here. Okay, so now what I'm going to do is I'm going to go into Amazon. So what I've done is, we have not pushed out official images yet, but they're not terribly difficult if you're familiar with building cloud images. So within the Git repo, I just pushed this last night because this is how I'm building these images. Just so if anyone understands Packer, I would actually love help from the community on Packer. So this is how I built the image using Packer. It's a very, very straightforward. It's using the Amazon EBS, and it just basically runs this one install script. there's just really not a lot to it. And then you have, this is the cloud config. If you look in here, the AWS, this is the cloud config, which basically all it does is just set up the data source. That's so we know to pull AWS user data. So yeah, so that's basically how I built these images that I'm going to show you now here. So then we go to, I'm going to go here to Amazon. And so I was going to do the demo on ARM64, but I won't because the ARM64, I can't launch as much software to kind of show some of the things because there's not, specifically some of the monitoring stuff I want to show you, I don't think is fully working on ARM64 yet. But anyway, so this image, like this image here, you can see here is ARM64. So it was surprisingly easy to create this on an A1 instance. I was kind of blown away how easy it was. AMD64 is actually really cool with the, as much as most people hate UEFI, the UEFI actually makes it pretty easy to deal with because it's a more known unit, at least to me coming from the Intel world. So so we're going to launch a VM from here. So I'm going to just click through everything. I actually wanted to do a Terraform demo. I'm not super great with Terraform, and I just ran out of time getting it. So I'm just going to click through everything. I'm going to pick a little larger machines here. The only reason for this is just because more memory, more CPU, things will run a little faster. But I could be doing this like all on these micros. Yeah. So here, so what we're going to do, we're just going to launch. The only thing I'm going to change here is just the security group, and I use this wide open one because I'm a developer and don't care about security. Just kidding. And then my key. Okay, so basically, this is going to launch this instance up in the cloud. Okay, so this will take just a couple seconds. It's usually not terribly long. However long I guess it takes to stage image and boot it. So what I want to show here is just basically we're going to launch an image, then we're going to use a cloud config to join the image, and then show how basically like we can take that and turn it into a large cluster real quick. And then everything I'm showing you can basically replicate with a Terraform script and just automate this whole thing. Okay, let me copy the host name here. That's still coming out, but I can go over here and type command. So again, Rancher is the user that we use for everything. So like when you set up k3OS, the root user is like locked out. You can't log in. There's no password. You have to use a Rancher user and then sudo in. So waiting for the cloud. It's taking longer this time to launch. It's running. Almost there. Okay, we're up. All right, cool. So, oops. Okay, so we got this up and running. So you'll notice, pull down the SSH key, so the cloud config, that integration, that's working. I can check, just real quickly that I got stuff launching and coming up in this cluster. Namespace, there we go. Yep, so these things are deploying and running. So I got that up. Okay, so I said before there's two ways to build a cluster. One is you launch the server and then it gets a node token and then you just join everything using that node token. Or you could use a shared cluster secret. Right now I'm just going to use the node token. So the way you find the node token, I think it actually tells you when you log in. Yeah, when you log in, it says the node token's here in this directory. Okay. All right, so that's my node token. So basically, what I'm going to do is I'm now going to launch a second VM. So I just want to say, okay, just launch another one like this. And the only thing I'm going to do different on this one is go to instance details, go to advanced, and I'm going to set up the user data. So here, just k3OS, server URL is going to be this IP. So HTTP 172.31.95. And then 201, oops, .201. Really hope I typed all that right. Okay, and then we put in the token. I'm going to expand this because I know the token's long. Okay. Oops, that is not the token. Let's go back here. Did not actually copy the token. paste that, close it with a quote. Okay, hopefully all that, I'll just quote this just for the heck of it. Make sure everything looks fine. Okay, so now I'm gonna go and boot this up. So if we have done everything right, use that existing key. If we've done everything right, then it should join to the cluster. This is like the most stressful part because we just have to kind of sit here and hopefully it works. I've ran through this demo a lot of times and it did actually work every time, which means it probably won't work now. Okay, so what we can do here is we're still on the server here. We're waiting for this node to join. Let me just write, let's just kind of watch the nodes. kubectl get node. Okay, so if things work, we should get a node in there. Okay, running, waiting. It's getting stressful. Okay, initializing. This is really an exciting demo at this point. There we go. Oh, worked. Okay. All right. So I mean, we just created a 2-node cluster. I don't know if that's impressive or not. It's kind of cool. It's pretty easy to set this up. And so the idea is once the Kubernetes operator, you can say like, okay, well, if I need to configure that node in any specific way, now that node will be configured. And then if the OS needs to be upgraded or the K3OS is the wrong version or they're out of sync or something, it will just kind of all reconcile itself. So let's launch more like this. So what we can do, because this is where like you can imagine if we had like a Terraform script to do this, is basically we can turn this into, oh yeah, this one I want, create template from instance. So we can basically create an ASG out of this. So an ASG is an auto scaling group. So it's pretty simple to just do this from the UI here. I can just create a template and then from this create an auto scaling group. And I'm just going to call this demo. And I want 10 instances, and then I just have to select the subnet. Next, configure that, and then review, and create it. Okay, so like now this should create an auto scaling group. So like this will give me, this should give me like, let's go back here. Launch configure instances. Okay, so this should be basically spinning up like 10 instances. And so an auto scaling group are nice things, fabulous things to run in Amazon, or most cloud providers have a similar concept. Basically, you can auto scale these based off of metrics, or you can just use them as a way to ensure that like I have 10 nodes and if one dies, it's going to delete it and it'll replace it with another one. You don't need to use ASGs to do like OS upgrades and roll out new AMIs because K3S is going to do that. K3OS will do that for you, but this is just a great way to kind of manage the nodes. So in theory, these things should end up coming up. So that's going to take a little bit oh wait, they're already coming in. Okay, so now I'm going to have a 12-node cluster here. So easily like I can just go in now and change the number and I get more nodes. So you can see how easy it is with like K3S and K3OS and all this stuff to just build these clusters. And then they should be like pretty much fully, they can manage themselves pretty much, the upgrades and everything. So we're making this super easy. So now I just want to kind of show this, kind of complete the picture of like kind of the rest of the Rancher stuff that we do of like, I mean, just how easy we're trying to make all this Kubernetes stuff for people. And so I'm gonna.
Aaron, is the version of Kubernetes? Preston was just asking if the version of Kubernetes always upgraded via K3S upgrade, or is it somewhat independent?
So
K3S.
Yeah, so K3S is tied to a specific version of Kubernetes. So it's like K3S 020 is going to be Kubernetes, whatever. The current version of K3S is 050, and that's Kubernetes 114.1. So it's tied specifically to a version of Kubernetes. Yeah, it's like we're really, would like to see people stay on newer stuff, don't lag too far behind. But we will be managing this in kind of a stable and beta channel. So there'll be kind of like different lines as we bring this towards GA. But for the most part, there's like a head version that we try to keep everyone on. very similar to
a couple questions as well about just HA mode and what the plan is for K3S HA. Do you want to just kind of explain that real quick?
Sure. Yeah, and all of this, yeah, I think all those nodes are all up. And right here, I'm just launching Rancher. I just ran the Docker command to launch Rancher. It just takes a second, it'll be up. But let me answer about HA. So kind of the big feature that's missing from K3S right now is HA. So, we have tons of people running K3S right now as just single masters. They're actually, they work really great like in a cloud environment, because if you just create a single master with an EBS instance and then a little bit of like Terraform or whatever, you can automate it. So if like it dies, it just comes back with a new EBS instance. And anyway, so people run these really simple, lightweight environments. But a lot of people, of course, want HA. So HA is coming for K3S and Q3, and there's going to be quite a few options of how to run HA. The way you set up K3S is going to stay the same. Is basically like launch a server and then join servers to it. And then we'll kind of manage, like you can then say which servers are going to be like the control plane and which ones are the worker nodes. You can do that based off of tags. By default, they'll just all become candidates to become the control plane. But it's going to be pretty much the same behavior of how you set up K3S today. But there's going to be a lot of options on where you store the persistent data. That's where it would get more involved or less involved depending on what you want. So what we're currently looking at is we will support etcd for people who like etcd. We will continue to support that. And you can launch it yourself or run etcd ADM or however you want to get etcd. So that will continue to work if you want etcd. We will also support MySQL and Postgres as a backend, which means you can just run like RDS or a cloud managed database, and then you can just launch instances and point it to a database. So like this is something we've getting like a lot of demand for people who want to spin up, like let's say like dev and test environments, spin up like a lot of clusters, and then they just use a shared database and point a bunch to like one RDS instance. So that's one option. And then the last option is the one that's more for the edge use case where you want super lightweight, and that's going to be where we're actually taking the SQLite database and we're doing a replication across nodes and then electing a master. And then so that one is kind of like the magical one that just works. There's some things around that, date, like that one is kind of like an eventually consistent node. So there's a possibility of like a small amount of data loss, but in an edge use case and all these various parameters, it typically doesn't matter. So it's super easy to run, but there's some little caveats. If you want like real hard consistency and whatnot, then you might want to pick a different data source. But anyway, so it's all coming. That's like Q3 is really where we're targeting for all that stuff. Yeah, and so the HA story is like that. It's really in the K3S development, not in k3OS. K3OS, there's really like no HA. It's it's a single unit. Okay.
All right. Thanks.
All right. So we launched. We launched a 10 node cluster using K3OS. Or 12 node cluster using K3OS. So you saw how easy that is to bring that up and get a full cluster. Now I'm showing you, basically you can go and launch Rancher. So this is our management project. This is kind of like the bread and butter of this company. And so here we can just go and import this cluster into Rancher. So if I just go, it just gives me this kubectl command to run. Go over to the cluster here, run that. So basically now that's going to register this cluster into Rancher. So now I can start managing this through Rancher, because it's like, why would you want to manage the Rancher? Like, so then Rancher starts bringing in all the kind of like administrative things you care about. Like K3S and K3OS are really just about making it easy to create a cluster, but now how do I manage it after the fact? Well, K3OS helps with a lot of the upgrade, and there's like kind of self-healing and stuff, but how do I get visibility to it? How do I set up logs, all that other stuff? That's like what Rancher starts doing. So it's like once I register this K3S, it's like, well, how do I get credentials and give people access to it? So it's like, well, Rancher will just easily make that stuff simple. So it's like I can add GitHub in a couple clicks here. Like I'll show you here how to set up GitHub. So it's like if I just demo, I just need to paste in this URL. This creates a brand new application. I just need to copy over these two things, the client ID and a client secret. Click authenticate. It's going to ask me to do the OAuth thing. Okay, so now like page refreshes here. So now I have this cluster set up and it's backed by GitHub authentication. So I can invite users from GitHub. I can do permissions and everything, all that fun jazz. So now I can get different credentials. So this kind of takes care of the whole security story. Then now once I have these, I have this cluster that I've registered here, I can go into the cluster and do something like, well, let me turn on monitoring. So now I just want to enable Prometheus monitoring on this cluster. So if I go and watch this, it's going to go and it's going to start deploying out Prometheus. So, in a minute or so here, I'm going to have Prometheus running. I'll show you all the stats and graphs and everything. And so, all of the so it's like with K3OS, K3S, super easy to get this stuff up and running. You register with Rancher. This helps with a lot of the monitoring visibility. There's other things I can turn on logging if I want FluentD, this type of stuff to pipe all my logs somewhere. And then you can imagine if it's so easy to spin up these clusters, and especially if I have like an edge use case, well, how do I manage applications across all these clusters? Like I have tons of these little things. So that's where you start getting into our like multi-cluster app story. So basically like I can go in here and say, every single cluster needs to have Datadog installed. And so here I can just describe whatever the configuration options are for however I need to do Datadog. And then here I select which clusters. So it's the projects, but effectively it's a cluster. So I've had 20 clusters. I can just say, okay, this needs to be on all these clusters. And then I just go and launch this, and it's going to go and deploy. So I can start managing these applications, and they're running across tons of clusters. And this will, it will show each cluster that it's on. So we start getting into like the full management of all this stuff, and but all this stuff we're just, we're trying so hard to make this stuff just really easy for you. So I wanted to show you just really quickly. It's like once I brought in those metrics, I can, it's like we get all these cool stuff from Grafana and everything. It's like this cluster that I just set up in a couple seconds and just installed Rancher, and or not seconds, I guess minutes. Now I have like all this information about what's going on in the cluster and all this. This kind of, I don't have any workloads actually really running, I think. Let me show you, or no, I bet you the data hasn't come in yet. It'll slowly come in. But so all this stuff about how much files. Anyway, so I'm just trying to show you kind of end to end of just, all the stuff that we can, how easy this is, or how easy it's becoming basically to run Kubernetes and manage all this stuff.
Darren, there's a couple questions on that topic. I mean, one question Alexi asked that he said with, can we actually manage the K3OS cluster and edit it from Rancher, or is that coming in the future?
Right. So
like we can with RKE today.
Yeah. So the key thing, and this is one of the things that was really important, is like when we did K3OS, is it's managed as Kubernetes resources. So however you can manage Kubernetes resources, that's how you can manage. So it's like you could hook it up to like a CI/CD pipeline. For us, what we imagine is that for a lot of the stuff, you'll basically use a variation of this multi-cluster app, because these apps, what they are, they're just Helm charts. Helm chart is just a collection of Kubernetes resources. So I can actually put the definition of it should be this version of OS and whatnot as basically an application, or one of these packages, and then say, okay, install that on the clusters. And then when there's like a new version of, of kind of, if I'm a big organization, I've decided, okay, now everyone needs to upgrade to this version. It'll say there's a new version available, and then you can deploy it. So you can manage already through like kind of the catalog stuff, but we are going to have in the UI specific tie-ins to K3OS. so that you can actually, because like today, like let's say like the nodes here, like we have node operations where you can like cordon and drain a specific node. So here you'll be able to do things like, upgrade this specific node, or, you'll be able to interact with the k3OS from Rancher. So, I mean, that's what's really exciting to us is, it's like once we basically take this unit, it's like we're taking the OS, the OS unit, and then presenting it effectively as a Kubernetes resource. And now we can just manage it the way we can any other Kubernetes resource. And so it just becomes just all that much easier.
All right, awesome, Darren. This is a great demo. Thanks for going through so much stuff. I do have a bunch of questions, a whole ton that I thought we could get to now. Let me jump through a few things.
So
well, before you move on, do you want to show that edit cluster to see what's possible with a K3S cluster? Because that was one thing that people were asking.
What, the edit cluster?
Yeah, like if you go into the cluster and you edit the version of Docker, for example, like Kubernetes, like you can with RKE. On the imported cluster, you can't really edit you can only edit the namespace and only edit the name of the cluster. You can't actually change the version. So that was the thing.
Yeah, so that's what I mean. So that's the stuff that's going to be coming. So again, this is an open source project. It's as it moves into more of a Rancher product, we integrate it to the rest. You will be able to go into here and basically edit. So like right now, there's really nothing you can change on because it's just an imported one. But once we import it, we'll know that it's K3S and K3OS. So then it will end up looking a lot more like, let's say, a custom cluster where you'll be able to change the a K3S version, any other parameters. Here you can see there's a lot of advanced options. Where's like the actual private, all these different things that you can do. You'll start getting visibility to kind of all of this type of configuration once we integrate it into the Rancher product.
Awesome. So a couple of other questions. Or did you want to demo anything else, or do you want to?
No. So the next thing I want to go into, but we are like an hour and a half in now, is talk about some of the internals. I do want to cover that, but I can be a little shorter on it because.
Well, a couple questions. Why don't we go through maybe like 3 or 4 questions here, and then we can jump to that. Sound good? One question from Christian was: Is the config.yaml the cloud init file that I can pass the installer, or is there a difference between config.yaml on an installed K3OS system and the one to pass to the installer?
So it's the same one you pass to the installer. So when we get into the installation stuff, there's the config YAML that's what you pass to the installer, and that's basically all the installer is going to do is just copy that file and put it on disk. It doesn't modify it, it doesn't even really look at it because it's the configuration of the installed system. Now there's more parameters for how to control the installation, but those ones are typically done through the kernel command line. So I'll show you in here. Let me show installation. When you're automating the installation, you typically set these through the kernel command line, and this will dictate how the installation itself runs. So this is kind of like the equivalent to like a Kickstart config or a Debian seed file or something like that, where you actually want to automate the installation.
Got it. Okay. One question from Greg. He said, are LXD/LXC or Snapcraft style deployments possible for K3S, K3OS? I enjoy using Docker and LXD for development, so I guess K3D might be an option as well. Do you want to just kind of chat on that?
Yeah. So this is so K3D, fabulous project. That was done by 2 guys in the community. I wish actually, I just know the GitHub handles. It's I will try 42, and then who's the second one? I should learn their names because I'm really super the K3D is great for running K3S on your laptop. It just launches them in Docker containers. But specifically what you're asking, can you do like Snap or whatever? So we are working with some people in the Ubuntu or community, I guess not specifically Ubuntu, but in that community to try to get a Snap package for K3S and K3D. So we were working on both of those. Someone has put in a PR here. We're trying to figure out, what's the best way to package this. There's some little things of little caveats of how we do things. We have some little issues around containerd, but anyways, yes. So in the end, we do want everything to be in snap packages. I don't know anything about flat packages, to be honest, if someone wants to contribute, but I know Snap as a decent ecosystem. I use Snap myself for quite a few things. So we do want Snap support. So we're trying to work towards that. So just kind of as that progresses, you know, we've found K3S, you know, like we're initially just targeted towards like Edge, but we found it's ridiculously popular in development like CI/CD, those type of things. So we'll continue to figure out more efficient and better ways to run it in development. But like right now, I think K3D is really like the best way for development. It's really cool.
Another question that was kind of was from Preston. He said, "Is there a thought or plan to map persistent and stable parts of the file system, like image, cache, config, to a partition outside of an A/B update pattern for OTA?"
Yeah, so we're still looking at like for the OTA and A/B update pattern, like exactly how to do that. I can show you how the OS is packaged right now. So we can work with that pattern, and basically what it is we're just trying to think. I don't think there's any issue with it right now. Is because the OS that would come from like the read-only partitions, like the A and B, like everything for state is stored on a state partition. I haven't specifically tested this, so there might be some little caveats with it, but we should end up being able to support like an A/B type thing pretty easily. So like the OS is just in the A and B partitions, and then you have a third partition for state, and that's where like the var and all that stuff goes. It'll become a little more obvious when I show the internals in a second.
Okay, well, maybe one last note. Adonis asked, how can we set nodes, roles, you know, for example, etcd, master, ingress, worker? Can you set that with K3S and K3OS?
Right, so K3S, we have an open issue or bug that we're not currently setting the roles. There's only 2 roles in K3S, which is like worker, master and worker. But all roles is annotations. So there's, or maybe they're labels. I think they're labels actually. So there's really nothing special about them. You can just set them. So K3S has the ability to set labels. K3OS also has like the labels support. So, you know, in K3S, we will populate automatically the built-in roles. But if there's any reason why like you want to do something custom around roles, you can just do it with labels today. Because they're just a special prefix on the label. Yeah.
Great. Oh, there was another question. Preston asked, have you tried or been able to get Knative with either Glue or Istio working on K3S?
Knative, so Knative, like if you just download the upstream package, we've had troubles getting it fully working on K3S. And we had it working on an older version, but then we upgraded to Kubernetes 1.14 and it broke. And from what we can figure out is that it's actually an issue. It has more to do with the issue seems to be in Knative itself. There was a certain assumption that no longer holds true necessarily in 1.14, and that seemed to break in it. But Knative holistic, like, so if you just download the package, go through like the sample or whatever, like one of the processes doesn't start. It's like the autoscaler. But we use Knative in other projects that we're working on K3S, and it works fine. So like we're still trying to figure that one out with the Knative community. Istio works fine. We haven't had any issues that I know of with Istio. I believe Glue should work fine. I don't know if you have a specific issue you've seen with Glue, but as far as I know, that should work. And the issue with Knative is actually a very simple one. It's like it's trying to ping the version URL, and it doesn't seem to have access to it for some reason.
Okay, well, why don't you jump into the rest of what you wanted to cover, and we'll kind of circle back to the rest of the questions as we wrap up.
Right, so I wanted to go through some of like the guts, the internals of like what we're doing, and this is like might start getting like super technical, of kind of how how we put together K3OS. So first thing I wanted to show just kind of how the thing is built, because it's very, very easy. Like I like simple systems. So the build system is very simple. All it is actually just a series of Docker builds. So our build scripts or whatever, it basically just goes and it runs these builds in an order with certain parameters. But you can see it's like, well, how do we build the base OS? You know, we start from Alpine 3.9. These are all the packages we install. So this is kind of like, this is the base of what you're going to see in user. Then how do we construct like the root FS? If you go in here, it's a multi-stage build, so it's grabbing some things from other things, but like some other ones, but we just go through and massage it a little bit. We put everything into the USR folder and clean out some stuff or whatever. But the point is like the whole build, it's super straightforward. It's pretty much just like shell scripts. Everything's done in Docker. You can build this on pretty much anything. Just clone it and run. You can run make. If you're doing this directly on a Linux machine, if you just run scripts run, you can launch the VM. So the build is super easy. Then in terms of like, well, how does the system boot and how does it work? Again, it's just all shell scripts. I really like shell scripts. They're really not that slow. So everything, the whole boot procedure, it's just a bunch of shell scripts. They're not super complicated. It starts with basically, let's see. Function. Oh, wait. Where's my init? Oh, sorry, here it is. It starts with this. So it just starts with this init script. Okay, so the whole thing is just basically a bunch of shell scripts or whatever. So it's pretty straightforward, and I really hope people can just read through and understand it pretty easily how we do everything. So most everything is in this overlay directory of kind of how the system is put together and everything. But when I was showing you the OS before, this is the file system you see when you're running, but this is not actually what's on disk. So because we construct this file system off of a couple different assets, so what's actually on disk is what is in these root FS tarballs. So these root FS tarballs, let me show you on another machine here. Let's see. K3OS dist artifacts. Okay, so let me show you what is in, let's see, like the AMD. Oops, I didn't want to extract it, but I did. Let me do a T. Gives me a little better output so you can see what this is. Okay, so this is actually, if you were to take a clean K3OS system and you looked at the root partition, basically what it's going to boot off of, not the initRD, but the actual root partition. This is what you would see. We have the sbin directory, which is just symlinks. You can see this symlinks to K3OS there. This symlinks to current, which ends up going here, symlinking here to current, which then goes to V020, which then eventually gets to your binary. So you can see the entire operating system. This doesn't include the kernel. Right now, this is just the user space. So it's really just two files. So K3S is a file. This is the exact same file you see from the K3S release. We don't repackage it or anything for K3OS. It's the exact same binary. And then we have one more binary that has K3OS. So what this binary is it's kind of a special binary that actually has a squash FS image embedded in it. When it boots, it has a squash FS image built inside the binary, and it places itself at /USR. So what the system will do is, as I said, this is the root here. So it's like you'll see root K3OS. So if this was I'll make a root here. So the installation of the system really effectively just does this. k3OS and strip components 1. That is actually how you install the system. So it's like when you get into image building and whatnot, it's like literally like the OS is just this tarball, and then you need the kernel and the bootloader. And I'll show you the kernel and the bootloader in a second. But this is the whole OS. So it's like what you can actually do is like you can actually just boot up an existing Linux system, extract this tarball into the root, and then reboot, and you'll be in k3OS, but it'll be using the previous, like whatever you previously had, kernel and bootloader you had before. But it'll just use the k3OS user space. So when the system boots, what it does is it makes a directory here in k3OS called data. So data becomes the state partition. So then as part of the boot is we need to figure out where you want to put that state. And so this is why I'm saying like I think this will eventually work fine for like A/B setups or whatever, is because this is like this tarball is effectively what would be in like the read-only partition. And then we would have a separate state partition that gets mounted to data, and then data is what ends up being the root that the user sees, because we just end up pretty much mounting the USR. So it'd be, you'll see a structure here. I'll show you this. Sorry if this is getting a little bit like, I'll show you here on this live system how this works. So we'll just mount the actual, we'll mount the underlying hard disk SDA1 to media, and so you'll see what it looks like on media. Okay, so here on disk you can see in like the subin directory, I just have that which links to k3OS. And in the k3OS directory, I then have the system files, which was the stuff I was just showing you, but it also includes the kernel. And then in data, this ends up actually being the root. It's the same thing that you find at the root of there. So the OS is actually packaged as like this very simple tarball of things. So when we start looking at it, it's like, well, how do we manage upgrade and how do we do that safely and all this stuff? So one of the approaches is actually doing like AB. That's what k3OS did. And I think that's a perfectly valid approach, and it works really well for like embedded devices and stuff like that. But you get into specific partitioning schemes and it gets a little harder. It's like, how do I support that in certain devices? And so sometimes it's just not feasible to do that. So like what we're doing should work with like that AB style. But the way that we're managing upgrades is all the operator is really doing is it goes into effectively the k3OS system directory. If there's a new version of K3S, it creates the version, it downloads the binary, and then updates K3S current. It will update the symlink and point it to the new current one, and then restart the process, and then make sure it actually worked. And then we maintain like a previous version too. And then if it doesn't boot, then you have to roll back to the old one, and that's where some of the failure modes get like a little more complicated of how to detect failure and how to roll back. But anyway, so this is how it's like, how do we manage this? Like, how do we keep this environment sane? And because we want to avoid things like RPM or Debian packages where it's like writing all these files, and it's like these are all simple, safe, atomic file system operations. Just create a file, flip a symlink, reboot. That doesn't work, flip it back. So it's like you could literally, like, something just goes totally south and everything's broken. It's like you can mount the disk, just change a symlink, get back to the old thing. So the kernel is managed very similarly. Basically, we have this kernel squashfs and then the initrd. So the only thing that's kind of special is the initrd is built for that system. It's not packaged because the initrd has to correspond to the k3OS version, and since those can vary, what those two is that, like, it's not, the initrd is not shipped as part of the package. Like, that's pretty standard in most Linux distributions, although I think Ubuntu Core might do it different. So the initrd is like, we download the kernel squashfs, and that includes some metadata inside of it. Has a kernel, firmware, all that stuff. and then we, from that, construct the initRD. So the bootloader that we use is, we basically never touch the bootloader during upgrade and all that stuff. We just pretty much keep a static grub config file. So in here you can see, we find the squash fs, we loop back mount that, we get the kernel out of the squash fs, and then we get the initRD from current. And this one is like basically the same thing, but it just has previous in it. So it's like the whole system, it's really simple. It's very kind of straightforward. I mean, I think some of the mounting, I mean, I guess it's not super straightforward. Some of the mounting of like how we're doing like the squash fs and whatnot, but the point is like on disk, it's just really a couple assets we have to manage. So if something goes wrong with a node, you know, it's like if you want to wipe out the state of a node, as I was saying on the disk, it's just this folder called data. I can just, you know, delete data that wipes out the state of the node. In fact, like we built this in so you can just touch this file called factory reset, and then basically on the next boot we'll wipe out the data partition for you. Or you can actually touch a file just called ephemeral, and then I don't know if that's spelled right. If you touch the ephemeral file, then on every reboot we always wipe out the data partition. Like there's never any state. Yeah. So yeah, that's kind of like some of the internals, the guts of how the system is actually worked. So like we treat, like we're very agnostic about like the bootloader. So it's like our installation will set up grub as the bootloader, but if you know you're using U-boot because it's an ARM system, we don't really care, like because the upgrade and stuff won't touch the bootloader. It's not really interacting with that. So like you just have to set up the bootloader in a certain way. So it's like we should be able to work with like any sane kernel, any bootloader. Like it should be super flexible so we can, you know, address all these crazy environments. Okay, so that's kind of the guts. And then the last thing I just want to cover was the installation. Like there's so many different ways to install this thing. So if you want to do an automated installation, typically what you're going to be doing is setting a bunch of kernel command line parameters. And this is all documented how you can do this. So basically you want to set a bunch of kernel command line parameters, and then you can pass it what's the cloud config that'll be installed into disk. So you can pass all this. So this approach works great if you're doing like a PXE boot, or you can use QEMU or KVM, because if you do like the QEMU approach where you just pass the kernel and the initRD and then do dash like append, you can just pass kernel parameters directly to it. So it's really super easy to script. You can automate this with Packer. So there's that approach of how to do it. All of this stuff with the kernel parameters and everything, it's at the end of the day is effectively just wrapping this one shell script install. So if you want to install the system, you can install it like an automated through a PXE boot, through an ISO. There's instructions here of how to remaster the ISO if you want to add in different parameters. So you can just create an ISO that like when it just boots on the system, it automatically installs. You can do things, there's like this mode where we have fallback where it's like, if we can't figure out how to boot the system, we run the installation. That could be destructive, but you know, for like ephemeral nodes, it's kind of great. It's like, you know, boot it up. If it's a brand new one, it installs. If it gets corrupted, it'll just basically wipe it out and reinstall. So there's an approach here of how to install the system where it's like, if I just boot, like if I have I'm running Ubuntu and I just want to install K3S or K3OS to a block device, then you just download that shell script, the install shell script, and then just give it the block device and then give it the URL to the ISO, and it'll install it to the block device. So you can create an image that way. There's this other way that's pretty fancy, which is for taking over an existing system. It's like if I booted Ubuntu, because this is how we actually create the cloud images. It's significantly easier in clouds if you can boot an existing OS and then modify it, take a snapshot, and then create an image. Like that's a really easy flow. So since K3OS doesn't exist in any, you know, clouds already, so what we do is we do this takeover method, which basically boots something like Ubuntu. There's certain assumptions about the OS, but they're documented here, where basically we boot the OS, we overlay k3OS into the root partition, and then we restart the machine into k3OS. k3OS will then go through the root partition and delete out any files that's not k3OS itself. So then that gives you a clean image, and then it shuts down. And so the Packer scripts are actually built off of that. So this ARM overlay installation is very similar to this one. For the ARM overlay, you can, again, like if you have an existing ARM system, like you can take a Raspberry Pi image right now, just extract k3OS, like the root file system, just extract that, strip out one component because that's the version, extract that to the root, copy in your cloud config, and then reboot. It will use the kernel in the bootloader of what was previously there, but it will use the k3OS user space. Hopefully we're just trying to make this thing as, a lot of different options for how to get this thing installed, so people can get it into all these different places, because, we're just, again, going back to that idea of Kubernetes everywhere. We're just trying to figure out how to get into all stuff. So
Darren, one question that came in kind of on this topic was, is it possible to connect a K3S node to a Kubernetes master, like a regular K8s node master?
No, not right.
Patching.
Yeah, so not right now. So now when we include K3OS, it starts to get kind of interesting. Like we're investigating approaches where, like, let's say we could actually just join it to an EKS managed control plane. So we're investigating that, but it does not work right now. So K3S worker will only attach to a K3S master, but we're trying to figure out and see if it's possible to attach them to like managed services. So you can just run K3OS as the worker nodes. Because like running K3OS with EKS managed control plane, we think is a really cool use case. It could end up being really nice.
Awesome. Anything else you want to demo? There was a bunch of questions, but I think maybe we can wrap up the slides.
No, I think that's
the remaining questions.
That's most of it. I mean, at this point, so we're still developing things, but try it out. The base installation, like the base OS, it does boot, install. You can configure it. We're mostly working on producing more images and finishing up the operator. But there's a lot there already. So I'm just excited to see what people might do with K3OS.
Awesome, thanks, Darren. So just a couple, things to wrap up with. If you are looking for more information, you go to k3os.io and you'll get into, the bits there. You can obviously find more information about K3S at k3s.io. The GitHub pages that Darren was showing are just rancher/k3os and rancher/k3s. If you're there, feel free to file issues. Really would love contributions. As Darren said, there's a lot of directions people are taking this. The K3D thing is a pretty good example of that. It's coming out of the community. We really would love to see any ideas people have for new projects. Feel free to get involved there. There's also a K3S developer channel in Slack. If you go to the Rancher Slack, slack.rancher.io, you can find a K3S developer channel there to kind of chat with other engineers and people working on extending K3S. If you wanted to get engaged on Rancher and just want to bring up Rancher, if you haven't seen that already, lots of different ways to get there. But if you just go to our docs, you'll find a quick start guides that go through lots of different ways to deploy and run Rancher. And with that, we'll take a couple more of these questions. Feel free to answer, fire in new ones. We won't leave until all your questions are answered. But thanks everyone for coming out today. It looks like we had a pretty amazing turnout, and we'll hopefully get through a bit more. So Darren, I'm going to make you the presenter again, so you can maybe show stuff as you're answering questions. And let me pull up the open questions, and we can kind of go through them one at a time. So Preston had asked a question about what is the path to hardware access and privileged containers, for example, GPIO on Pi, using sysfs. Do you know anything about that, or I don't know much there? So
yeah, I mean, so there's you can just launch regular privileged containers. That's nothing's like restricted there or anything. So unless you turn on restrictions like pod security policy, but so you can just launch a pod. What a lot of people will do is you bind mount in the root to a folder like host, and then you can bind mount in the sysfs. You can either directly access the sysfs like as host / sysfs, or you can then bind mount that over your existing sysfs if you want to get to some of those things. So I'm not super sure about like if like sysfs is even like for the GPIO stuff, if that's already just like if you even have to bind mount over the host one. I'm not sure if like it's going to be hidden in the container by default, because you're going to want to launch a privileged container so you can get access to those. I know the dev is like we can start a whole new dev, but sysfs might actually be the same. So it's like you might be able to use it, but it's feasible. You just might have to put in like one little init script into your container to set it up.
Awesome. Another question was in from Banir. He asked, how does the k3OS architecture behave in the security issue as an encryption key, CA, and container audit? Do you need third-party solutions? I don't know if that's clear enough.
So K3OS doesn't really do anything around certificates right now. That is going to be like K3S specific to the Kubernetes distribution. Right now, K3S does work as its own CA, and it is issuing certificates to the cluster and managing all the certificates in the cluster. So we currently do not have support. Well, okay, so we don't have support for interacting with an external CA beyond you bringing the certificates. So we're refactoring some of the certificate management of K3S right now. So it should be documented what the certificates are and what they're used for. So it is possible for you to, like K3S needs to work as a CA, but if you can get a CA to sign you a CA certificate, then we can issue certificates to within that cluster. So it is slightly, I think it should end up being fine of like basically you can generate the certificates, and then put them in the kind of the right directory for K3S. The only issue is going to be if you have a requirement that says like you can't like we can't issue certificates, because it does automatically issue certificates to nodes. So yeah, that's kind of the story there. If you have specific requirements, open up a K3S an issue in GitHub on K3S if you haven't already, and just explain your requirements, and we'll see what we can figure out, because those things matter to us. We deal with a lot of enterprise, kind of like all these kind of restricted environments, like different government things and whatnot, and so we do care to make it pass whatever audits we need to.
Another question, Darren, is Joe said, when would someone install K3S in the cloud versus RKE?
Yeah, so initially we targeted K3S to be towards this lightweight idea of creating this smaller distribution. But in doing that, like in order to make it work in these lightweight environments, is we had to make the installation easier. So there's been kind of two things that's come out of K3S, is it's easier to manage and it's smaller. So RKE, the reason why you're going to want to run RKE is because you get the full-blown thing, and it might do some things that K3S does not do. But that delta should basically go away over time, because we're seeing that we can basically keep the minimal footprint of K3S that we have without really losing any functionality, as we've been investigating this more. So right now, K3S is kind of like, so there's two primary reasons why you're going to be using RKE. One is that's a supported GA product. That thing, that's well tested. But beyond that, it's your full-blown distribution. It can do absolutely everything with Kubernetes. K3S right now is more limited, but we're trying to remove all those limitations, and we don't really see that there's a lot right now. So I do see over time that the ease of use and stuff that we've done with K3S will basically end up kind of replacing RKE as K3S becomes more stable and like a GA thing. So over time, I'd really like to see these two products merge. But right now, RKE full-blown supported is kind of like your enterprise grade.
Preston asked, can you compare node token versus secret? Since node token is not generated till first server run, secret seems easier for fully automated setups on edge, maybe via DHCP. Can you comment on that?
Correct. That's basically, that's pretty much what it is the node token is generated on the first installation. The node token is also kind of like, has some cryptography in it or whatever. So it ensures that like, if you give the node token to a node, that the node token helps validate the server it's talking to. So it's kind of like that use case in SSH where like the first time you talk to something, it's like, do you trust this? And you have to say yes or no. The node token kind of gets away from that. The node token will only work with a specific master because it has a hash of a certificate in it. And so the node token actually is slightly more secure, but the cluster secret is what is best for automation as long as you can generate a good random value. That one is significantly easier to automate. And so that's what, like when people are using like Terraform scripts and whatnot, we're seeing people just go more towards the cluster secret. And so we're actually gonna try to see if we can improve some of the cluster secret management. Because right now it's pretty straightforward. I mean, it's just like, it's just you just give it some value. But if somebody for some random reason happened to know that same cluster, but it's kind of like if you just generate a long enough random value, then it's fairly secure.
There was a question from Matthew. He said, when I launch k3OS, applying k3os.install.device equals dev/vdb at the grub screen seems like it's a no op. Can you demonstrate running the installer with an alternate install device? Is that, do you want me to reread that?
No, I think, okay, so if you're gonna do it from the command line, make sure you put k3os mode install. Maybe you miss, because if you don't put a mode install, it doesn't go into the installation mode. It will just boot the OS. So like that's like, if you're trying to just automate the install from the command line, you have to put one of these two parameters. So that's what will kick off the installation mode, and then whatever in the device, it should just take that. And then if you set silent, it shouldn't ask you any more questions. I mean, I can try real quick and see what happens. I mean, I wouldn't doubt that there's a bug. That is definitely, can I create measure? Oh, I already used that name. Okay, oops. Okay, so I should be able to k3os.mode install, and then I should say k3os install.device dev, and I'll put SDB, which doesn't exist, and then k3os install.silent. Let's see if this works. This is where you get to see if I'm. Ah, shoot! The prompt didn't respect silent. Okay, well, that's a bug. But anyways, so you can see device was set to SDB, silent is true, which the stupid prompt, that's a bug, I'll fix that. It's not supposed to prompt here if you want to continue. But then I hit yes, and then the installation failed because SDB doesn't exist on this machine. But hopefully that should work, so hopefully that answers.
Yep, that's great. Okay. Darren asked, he said, are there any plans on doing some more with HPA in the Rancher UI?
Yeah, that's I mean, that's like one of our 2.3 features is we'll have full management of HPA. Yeah, so I mean, that's currently on the roadmap. I know that that might even be in one of the early previews. So
great. Another question from Aman. He said, how does K3OS differ from something like Talos, T-A-L-O-S? I'm not familiar with Talos. Do you know that?
I think Talos is really a completely different concern. I'm not quite sure because I'm Googling real quick to see if it's the one. No, I have no idea. Yeah, I haven't actually heard of this. So I will look into this. I haven't actually seen this one before, so yeah, might be interesting. Maybe there's something to. Okay. Who's the company behind this? No, Talos Systems.
Well, it's worth looking into.
Yeah, I will check this
question.
out. This is new to me.
There was another question from Stephen Sheehy. He said, is the Kubernetes operator a separate project that can be potentially used outside of K3OS to manage Kubernetes upgrades, or is it's really quite coupled with K3OS?
It will apply to K3OS and K3S standalone, but that's it. Okay. I don't think it's going to apply to anything else because it's like the code that we have to write for K3S and K3OS is so simple because it's so simple to upgrade these systems that if I was to try to then take that approach and use it for like Ubuntu and kubeadm or something like that, it's just a lot more code and work, and it's like it just doesn't even make sense. Those need significantly more involved systems. So it's going to be pretty much tailored to our K3OS and K3S, but it will work for standalone K3S.
Great. Let's see here. There was another kind of, Joe had just asked, can the OS config be run unattended for use with something like Packer? I think you already showed that, but just.
Yeah, for sure. So that it works fine for, so again, there's like a, and this is what I'm showing here on disk here. This is the GitHub repo. So if you go to package, Packer, like here's like an AWS one. So yeah, so it should work. This is using what I was describing before, which is called like the takeover installation. So this just basically runs that, reboots the system. In the reboot, it reboots, cleans itself up, and shuts down. So unfortunately, there's like a pause for 3 minutes. There's a little technical issue with the SSH user, but anyway, so yeah, you can do it through Packer, and we'll be producing Packer scripts for all the major clouds, because we'll be maintaining those images.
Okay. One more question. What's the timeline for GA? I know that's kind of a hard question to answer, but do you want to talk a little bit about where we're at?
Yeah, I mean, GA that one's super hard. I mean, I would hope we can get to beta by the end of the year. I think from when we go to beta to GA, a lot of times that's kind of end up dictated by actual like customers or business type things. But I think we can. The only target I have right now is beta, and so we're trying to get like the features, like the images and the operator. We're trying to get that done over the next 2 months, and then whatever bug fixes and things like there's always things we never thought of, and so we're hoping we should be solid beta by the end of the year, and then GA will be sometime after that.
Another question, Herman said, are you guys thinking about a takeover script to convert Windows machines into K3OS nodes?
Yeah. As somewhat jokingly though, is I am interested in K3OS running in Windows for subsystem, Windows WSL2, Windows subsystem for Linux 2, which runs the full-blown Linux kernel. So when I saw that, I'm like, ooh, I'm going to run K3OS on Windows now. So yeah, that would be great.
All right, my last question, if you guys have a question that I didn't answer, or maybe I said I'd ask Darren but forgot to ask him, please repost it now. But the last one I have is from Preston. He said, for cloud installation, how are things like cloud-specific ingress controllers injected into the master template?
Right, so you don't really, okay, so if you want, I mean, I wouldn't bake that into the image so much. I would put that more into the cloud config. So when you bring up, so I would use the write files because, where'd it go? Okay, so in the configuration here, I would use the write file approach in the cloud config, which would then write a Kubernetes manifest. And the way K3S works is there's a folder var lib rancher K3S server manifests. If you put any Kubernetes manifest in there, it will automatically deploy it. So what you do is you just, in the cloud config, you put the manifest that you want to be deployed on the master, and then it will deploy that software. So you can kind of package that up. And we have in K3S special support for Helm. So you can write a Kubernetes manifest, which is a description of the Helm installation. So if things are already packaged as a Helm chart, then it's super easy. Like the manifest that you would write, like traffic is an example, this is how we install traffic, would be something like that, where you just say, okay, I want this chart, these are the parameters, or you can do something more complicated with the actual values file. And then that will install the stuff. So like you can package up a master, like the server with the full configuration of yeah, like cloud providers, ingress, all that stuff. So this should integrate really super easily into that.
Okay, one last question. What is the default password of Rancher users when I install k3OS from bootstrapped installation by install.sh?
There is no password if you don't set a password. So if you're using the install.sh, that's kind of a little bit more of an advanced mode, and it asks for a cloud config file. You need to create a cloud config file with the password or the SSH keys in it. So there is no default password. It's just basically it's going to give you a system that has no password, like, which is useful if it was joining a cluster and then it was managed by the cluster. But that is the default. So like the install.sh script is a little bit more raw. So like what you can do is if it's, to kind of bootstrap that of creating the cloud config the very first time to run it through the install script, is you can run the interactive installation. When the system reboots, just look at k3OS system config.yaml, that file, that's going to be like the contents that you need.
Okay. Another question, how do you supply an HTTP proxy to K3S? Is this parameter the right one? Cube-proxy-arg value. I can make you the presenter
no.
if you want to show something.
Yeah, no, so that's not the right parameter for the, if you want to do.
If you want to share your screen, I just made you the presenter again.
Okay. Yeah, so so for the cube, if you want to set an HTTP proxy, you just need to set the standard HTTP proxy environment variables, like HTTP_proxy, HTTPS_proxy, the no proxy. Set those environment variables, and the system respects the environment variables. So typically, if you're using like the install script, which sets up systemd, or OpenRC, there's environment files that you can edit. Let me see if I can remember what the systemd system. No, it was, yeah, okay. You can basically in the K3S service environment. What the heck is that? Oh, that's something else. But anyways, in this file, you can put HTTP proxy in there, and then systemd will read that and then pass it to the process.
Cool. All right. Well, with that, I will thank Darren for answering all the tough questions, and thank everyone here for asking over 300 questions over the course of the last 2 hours. these are a lot of fun for us to do. So thank you all for coming out and being so engaged. If there is anything you ever need, Darren and I are both on Twitter and pretty active. So you can find me at SMW355 and Darren at I Build the Cloud. We're both also on Slack, and you can find us on email, Shannon at rancher.com, Darren at rancher.com. So feel free to reach out. We really love talking with you all. Have a wonderful day. Darren, I'll talk to you soon, okay?
All right.
Bye, everyone.
Bye.